Okay, so now you guys have watched the video talking about the special right triangles. So now we're going to get into finding values of special right triangles. But with this one, we don't actually have to have the knowledge of the special right triangle, or if we do, we can help. So I'm going to show you guys two different ways. One uses a calculator and one doesn't. So in my mind, the one that doesn't use the calculator is definitely the best way, but to each their own. So the first thing we see is this is our triangle, and we need to find the value of x. Now, if you see, that's a right triangle that has a 30 degree. That means that this right here is a 60 degree. If you look back into your notes, the 30, 60, 90, whatever the side length of what's the hypotenuse, so that in this case 8, the side that is across from the 30 degree angle is half of it. So that means this is 4. And then what is across from the 60 is the 30 measure, so that would be 4 times root 3. So literally in that moment, I just solved what that angle is. Now, if you guys didn't pick up on that, looking at a really rough sketch, say this is a 30, this is x root 3, and this is 2x. So looking at, if you guys think back to triangle similarities, where you guys talked about dilation, basically you're stretching your equation from a 2x and turning it to an 8. So that means x is 4, and then you have x times root 3, which is 4 root 3. All right, that's the first way. There's no calculator needed. Holy moly, I think it's pretty easy. Now, if you need to use the calculator, you can. What you're going to do is you're going to look at this angle. X is adjacent, and hypotenuse is 8, okay? So we have adjacent over hypotenuse, which means we can use cosine. So that means we're going to look at cosine of 30 degrees equals x over 8. In order to get x by itself, you multiply by 8. Then you have 8 times cosine 30. You plug it into your calculator, and if your calculator, which it should be, is in degrees, you should get 6.928. Now, if you look at that and you're like, that's gross, it is. The reason why it's gross is because it's trying to round off that value of what cosine 30 is. So 6.928, and that's rounded. If you go ahead and check it, 4 times the square root of 3 is 6.928, and so on and so forth. So you see that they are identical. However, this one says that x is 6.928 and gives you a decimal, which is not as accurate, but rounded, they are the same. Now, my preference is if I don't have to use a calculator, I'm not doing it. But you won't always see special triangles, so you may need to use this calculator format with these ratios for non-special right triangles. So that's anything other than 30, 60, 90 and a 45, 45, 90. So 2 ways to solve it. One's using special right triangles and one is using any. Hopefully that makes sense. You guys will have a couple more examples that I'm going to go ahead and show you guys at the end of the video, or the end of the slideshow.